And the last little review slide. Sex-linked traits. Sex-linked traits. Remember, these are traits whose genes are located on the sex chromosomes or the 23rd pair of chromosomes. So, remember these, if you're a female, to be a female you have the genotype XX, and if you're a male you have the genotype XY. Remember that the female X chromosome, or just the X chromosome, is much larger than the little Y chromosome. So these genes are almost always found on the X chromosome, but not found on the Y. That's why these traits are much more common in males than in females. But another little Punnett square to remember how to do it. So we can, we got hemophilia, or actually we got color blindness over here. Big N is normal vision, little n is colorblind. Let's try one. Let's say that the female is normal, but she is a carrier. So she has normal vision, but she does have one recessive colorblind allele. So to make her female, I gotta have XX. Gotta have it. And now her alleles. She has one normal, one capital N, and her other one is the recessive colorblind allele. So remember, she is not colorblind because she does have one of the dominant normal alleles. We're going to cross her with a colorblind male. So first, to show me that it's a male, I'm going to put X and Y. Got to have that. Now, he's colorblind, so his allele, he's got the recessive colorblind allele. And remember, do not give me anything right there. Nothing. No allele on the Y, because the Y is too small. The Y chromosome is too small, and the allele does not fit on it. All right, so that is a carrier female crossed with a colorblind male. So I'll go ahead and put their alleles over here. X big N, X little n, and the guy is X little n, Y, and fill in the box, X big N, X little n, normal female, but she is a carrier, X big N, Y, totally normal male, X little n, colorblind female right there, and X little n, Y, colorblind male. So in this case, 25% of the kids would be colorblind females, 25% would be normal females, 25% would be colorblind males, and 25% would be normal males. Now we're going to move on into pedigree analysis. Pedigree analysis is basically just like a family tree. So these would be like the grandparents, and they have these kids. So it's kind of like you're going to be solving a puzzle. The squares are always the guys. The circles are the girls. And then these are their kids. So they had a son over here. They have a son right there. And they also have two daughters. The green in this case is they're affected by some sort of disease. So the circles, the green circles, those are females that are affected with a disease. The green squares are the males. And the yellow circles are females that are carriers of this disease or whatever this trait is. So remember, females can be carriers because females have two X chromosomes. So they have two alleles for these traits. But if they get a normal allele, then they don't have the disease themselves, but they are a carrier. All right, so we're going to try some of these. And the trait we're going to look at today, this is an autosomal recessive trait. Autosomal, so this is not sex-linked. This is not a sex-linked trait. This is on the autosomes. Remember, the autosomes were chromosome pair number 1 through 22. And this trait is called albinism, or being what's called an albino. It is a recessive trait. That means the only way you can have this condition, albinism, which is basically your skin and your hair do not make, and your eyes as well, do not make any pigment or color. So you have very light skin, very light hair, you have no pigment. So the only way you can be an albino is you got to have two recessive alleles. So albino. It's little a, little a. Both big A, little a, and big A, those are both going to be normal. All right, so we're going to track this through a family tree using a pedigree chart. And here's some animals in the wild. Like here's a little squirrel that's an albino. So you can see he's got red eyes. It's all white fur. Now, usually in the wild, this would not be good. I mean, if you're going to have a pet squirrel, maybe you'd like them to be white. But you can see this, all the brown dirt and bark, and it's hard for the little white squirrel to hide from predators. Same thing for this Mr. White tiger over here. Now, if he lived in the snow, that would be great to have his white fur. But in the jungle where tigers are found, it's much harder to see this guy coming than a white tiger. And here's an albino dolphin. Here's a girl that has albinism. And here's a little sea turtle. All right, so now we're going to try a simple one. So first of all, remember the squares are the guys. Males are the squares. Females are the circles. Anybody who's shaded in, if you're shaded in like this male way down here, you have the albinism trait. So everybody that's shaded in, we know their genotype. They got to be little a, because albinism is a recessive trait. So the only way you have it is you got to have two recessive alleles. So we also know this mother, she's actually the grandmother. We know her genotype. She's got to be little a, because her circle is shaded in. And same thing with this daughter here. She's got to be little a. Now, that leaves us quite a few other ones that we do not know yet. But we can figure them out just by a process of elimination. All right, so if you look down here at this sun, he's a sun because he's a square. He's got little a. Well, where did he get those two alleles from? Where did he get these two little a's? Do you think maybe he got them from his parents? Yeah, we should know that now. He got one of those little a's from each parent. So, we know that both of these parents have a little a. They have to, because how would their son have gotten a little a unless they got it from the parents? Now the question is, for those two parents, what's their other letter? We know it can't be another little a. How do we know that? Well, simple. If it was another little a, that circle would be shaded in. If it was little a, it would be shaded in. Same with that square. So it cannot be little a. It's got to be the dominant capital A, because the parents do not have albinism themselves. All right, so now let's see if we can figure out what this guy's genotype is up here, the grandfather. Well, you can see one of his daughters, we know it's a daughter because it's a circle, has albinism, little a. Well, where did she get those alleles from? Where do you think? Ding, ding, ding. Yup, she got them both from her parents. One from each parent. The two, the circle and the square up there. Now, she got one of those little A's from her mom. This circle right there. She got one of them, but she had to get the other one from her dad. Therefore, we know this dad has a little a. He's got to, because he gave one of them to his daughter. And we know his other one has to be a big A, because if it was another little a, this square right here would be shaded in, but it's not. So we know that's a big A. Now, this son right here, we know his genotype because he's got to have a big A, because his box is not shaded in. Now, what does his other allele have to be? We know he got the big A from his dad, because that's the only parent that has a big A. And from his mom, we know which one he got. He had to have gotten a little a, because that's all the mom has. She just has little a's. So boom, there it is. By looking at the traits of that family, we were able to figure out the genotypes of every single individual. So, I mean, doing these little easy questions, how many grandchildren does the original couple have? Well, they got one. They have one grandson. What is the gender? It's a male because it's a square. How do you know that the wife of the son is heterozygous? The wife of the son. I don't even know what that means. All right, next page. All right, we're going to try another one. Starting off, we're going to fill in all the ones that are shaded with their genotype because we know those. They got to be little a, if they have the recessive trait. So we can fill all those in. All right. Then we can try to figure out what the other ones are. All right, so let's start at the top. Well, we see this person right here has two little a's, two recessive alleles. And once again, there's only, and that's a girl because it's a circle, there's only one place that she could have got those two recessive alleles from. Where do you think it is? That's right, her parents. She got one little a from both parents. So we can go ahead and give them each one little a because they got to have one little a to give to their daughter. Now, their other letters should be pretty easy to figure out. It can't be a little a because if it was, their box and their circle would be filled in. Therefore, they got to have the big capital dominant A in order to not be albinos themselves. But they're both carriers. That's why they were able to give that trait to their daughter. Now, let's see here. This guy right here, he's the son of these two people up here. He has to have a big A. We know that because he's obviously not little a, little a. If he was, his box would be shaded in, but it's not. Now, if you look down here to his son right here, his son has the genotype of little a, little a. Well, once again, I know I've asked this like 2 or 3 times. Where did this son get both of his recessive little a alleles? Where do you think? If you said his parents, you would be absolutely right. He got one of those little a's from each of his parents. Therefore, we know each of his parents have to have a little a. Now, his mom, we know she's got a little a because she gave it to her son, but her other allele has to be the capital A because if she was little a, her circle would be shaded in. All right, now we're going to go to this lady over here. Their daughter has albinism. She has 2 little a's. And once again, where did she get those little a's from? If you said one from each of her parents, so one from her mom, one from her dad, ding, 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 you would be correct. Now, her dad's got 2 recessive alleles, but he only gives one of them to her. The other one has to come from her mom. So I know she's got one little a. And since her circle is not shaded in, that tells me that for sure her other letter is the capital big A. Now, the only thing we don't know, we cannot figure out this girl's genotype. The reason is, we know she has a big A because that's her box, her circle is not shaded in. So we know she's got at least one big A. But she could have gotten another big A and she wouldn't be an albino. Or she could have gotten one dominant and one recessive. Either way, she would not have albinism. So we can narrow it down, her genotype, to big A, or big A, little a, but we cannot figure out exactly what it is by just looking at the pedigree chart. All right, I don't know why I did this. This pedigree chart, not that exciting, but remember, once again, square equals male. If it's shaded in, that means they have that recessive trait. This female over here, that's the mom. She's normal. She has the dominant allele, but she is a carrier, so she is able to pass on that trait to her kids. So these would be their 3 kids. Of course, they're all 3 circles, so they're all girls. And this is the only girl that actually got the recessive trait of albinism. All right, moving on. We're almost done. What we got? Like 3 more slides left in genetics, and we're done. Our exam will be next class, so feel free to do some studying, doing some quizzes between now and then, so you can get a good grade on the test. All right, a person's karyotype, or an organism's karyotype, is just a pictorial representation of an organism's chromosomes. So basically, how many chromosomes do you have? How many of each pair do you have? And how big are the chromosomes? That's basically an organism's karyotype. So this, I don't know why there's a big space here, but this is the karyotype of humans. Remember, we have 23 pairs. So here's chromosome pair number 1, they're the biggest, 2, the second biggest, 3. They get smaller and smaller. Chromosome pair number 22 is tiny. Here's chromosome pair number 23, the sex chromosomes. Can anybody tell me if that is a male or a female? I'll wait for your answer. If you said that was a female, give yourself a pat on the back, because yes, that is a female, because they have 2 of the large X chromosomes. If it was a male, the other chromosome would be a little Y chromosome, but it's not, so that is a female. All right, one chromosomal abnormality that we're going to talk about, other than mutations, which we're going to get into again and when we get to evolution, but it's this term called nondisjunction. It's a really weird word, nondisjunction. The reason it's weird is the word junction means to come together. Junction means to come together. So therefore, disjunction would be to not come together or to go apart. So we had junction was come together, disjunction was not come together or go apart. So what's non-disjunction? Well, that goes back to coming together again. So why they didn't just say junction instead of non-disjunction? Anyways, non-disjunction is a failure of chromosome pairs to separate away from each other during meiosis. So during meiosis, they're supposed to be ripped apart from each other. Remember how in anaphase, the chromosomes are ripped apart? Well, every now and then, the chromosomes are unable to separate. That can lead to basically one of 2 things. If that gamete is involved in fertilization, that individual, instead of having 2 of each chromosomes, one from mom, one from dad, one of their chromosome pairs, they might have 3. So they might get maybe 2 from mom and 1 from dad. And that's called being trisomy. Trisomy. If you ride a tricycle, it's got 3 wheels. If you're trisomy, one of your chromosomes, it's supposed to be a pair, but since the chromosomes failed to come apart from each other during meiosis, the 2 mom chromosomes went together, you actually end up with 3 of whatever chromosome that is. And that's trisomy. Now, the opposite of that is sometimes when the chromosomes fail to separate during meiosis, instead of getting an extra one, you'll actually get one subtracted. So you might just get a chromosome, it could be anyone, like chromosome number 5 from your dad, and whoops, chromosome number 5 from your mom never made it into the egg. So you're actually missing a chromosome. And that's called being monosomy. Mono means 1. So non-disjunction is just a failure of chromosomes to separate from each other during meiosis, which results in having too many or not enough chromosomes in the gametes, and then later on the kid. And just real quick, some things that can happen like Down syndrome. Most people are familiar with that. It's trisomy of chromosome pair number 21. So if you look at this kid's karyotype, normal 1, normal 2, normal 3, normal, until you get down here to chromosome pair. It's supposed to be a pair, number 21. Non-disjunction caused this individual to have 3 chromosome number 21s instead of 2. And that leads to what's called Down syndrome, which is mental retardation, a characteristic look. And let's see if you could tell me, is that a boy or a girl? If you said it's a boy, good job. Because they got the X chromosome and they got the little baby Y. And here's another thing that can happen from non-disjunction. Remember, non-disjunction. That's what causes this. This is called Klinefelters Syndrome. And it's also a trisomy. But it's trisomy, you get 3 of the sex chromosomes. So instead of being a normal female of XX or a normal male of XY, people with Klinefelters have the genotype of XXY. Whoops. And this does happen. So it was the female's chromosomes. During meiosis, they forgot to separate from each other. So, this mom was supposed to only give 1 X chromosome to her kid, but she gave both. So this kid, it's not lucky to get 3. You want to have 2, like, normal. So in Klinefelter syndrome, it's kind of a blending of male and female characteristics. You get the long, slender legs like a female. You get more of the wider female hips, not the narrow male hips. Narrow shoulders like a female. You do have small male genitalia. You get the male pattern baldness. So basically, it's kind of a combination of male and female's traits. But what you need to know, it comes from non-disjunction. Non-disjunction. Hopefully you can read that. I don't know. Non-disjunction, which is a failure of chromosomes to move away from each other or separate during meiosis. Thank you very much for listening. Hope you enjoyed it, and I'll talk to you next time. Remember, quiz or test or exam, whatever you want to call it, is next class.